Okay, hey everybody, this is Brad here down in his workbench, and I was asked to do some videos on some early Williams electronics video arcade boards. Primarily I've been doing Defender, but I've gotten quite a few Stargate, Joust, Robotron, Sinistar stuff. Anyway, so I figured we start with the easiest board first. The widget or interface board. Basically, this will take all your switch joystick inputs. There's two 10-pin headers here. Brings those in. There's some inverter buffers here, so they're ground triggered. Pull-up resistor, keep them high. They come in pulled low, and these will invert, so they'll actually output a positive. Then you go through some multiplexers here. This is primarily for cocktail games. It's really the only reason you need these ICs here. So depending on the game thinks it's player 1 or player 2, it'll switch the inputs and route them to the same pins on the PIA, the peripheral interface adapter. So I'll show you a couple of the ones we've done so far. I've done quite a few of these. So everyone gets a new ribbon cable connector here, the board connector. I do that on an as-needed basis. I have brand new bags of them. They're not really difficult to change. Lifting some of these traces, if you're inexperienced, is easy. Some of the boards are in different quality levels. If they've been in high heat for a while, the traces can lift easier. So if I see to me that the board looks a little riskier and the connector's fine, I definitely will not monkey around with it. It's the old don't fix it if it ain't broke scenario. So the first thing I do on these, I remove the labels, and I'll do a different video on that because that's applicable to all the different boards. There's some tricks for that. I do preserve the labels and re-adhere them, and I have some special archival adhesives and stuff that I use on them. I've read some books on it, and I've done some paper conservation as well, different outside of the arcade game here. So this is one that's done. Again, gets a brand new electrolytic capacitor. These are 25 volt, 100 microfarad. These are Nichicon Muse. They're kind of the audiophile. They have a low ESR, equivalent series resistance. They're just really good caps. There's a whole different school of people out there. Oh, these are better than those. At the end of the day, there's not much difference between the different electrolytics, in my opinion. It's a couple of strips of aluminum, some electrolyte, some paper, and there's not a whole lot there. But these are pretty industry-wide, well-established caps, so we go with those. Ribbon cable, I buy it 3M. No sense in cheaping out because these things are a common failure mode. 28 gauge, 100-foot spool, 20 conductor. Pretty finely stranded wire internally, so it's real flexible. You don't want to worry about breaking it or anything. And again, all 3M, the termination ends on the headers, these are all 3M. Getting harder to find a different color. Pretty much when you find these things, you know, they've made them in grays and blues and whites over the years, different companies. You know, you just want to go with something good quality. You don't necessarily want to mix and match all the different, you know, gold-plated, tin-plated. You can end up, if you have dissimilar metals, you get galvanic corrosion, electrolysis happening, and you know you can get some connection issues over time possibly. There's a whole debate out there on those, whether the gold-plated terminals cause a problem. I personally, gold is pretty inert, and I haven't run into any issues with that. But these are just tin-plated, and just like everything on these boards pretty much is. So we'll go with those. So typically what I do, those, I'll make up a bunch of these at once, the ribbon cables, and then after I recondition the boards, I'll just mount them. So I'll have the cables cut to length, and I'll terminate this end that goes to the NPU board. So I'll make up one of those and kind of just show you how to do it. I take the box, 100-foot spool or whatever's in this one right now. Get a little, getting a pin out of the drawer here. Get a little measuring tape. I typically cut these just from experience of measuring these. They're roughly, here's some ones that have never been monkeyed with. These are factory, and they're basically 5 inches. I give them about 5 1/4 when I do it, and to be honest, this box here, let's hold it this way. This is a new box, and the end on it isn't very square. So I use this table, and I'll lay the cable on the line here, and then I have the perpendicular line here, and I just use it as a reference for the little metal rule here. And then I've got a X-Acto, real sharp blade. On eBay or Amazon, you can buy these X-Acto blades pretty cheap. Buy them in a 100-pack. I think it's under $10 probably. So that's the end I just cut off. You can see it's narrower at this end than that, so it wasn't square. Here's the blades actually. Techna Edge number 11 hobby blades. These are carbon steel. They come in a little pack with some oiled paper, probably like a Cosmoline on there, just to keep any corrosion off of them. Probably shipping from China or wherever they're made on a boat, so they got to make sure they don't rust up. So there's however many's left in there, but it comes with 100, and it's, you know, again, under $20 for sure. And so I might as well swap the blade out here just because. And then I do keep a here on my workbench. I've got some sharps, and I have one of these used sharps containers. It's you know, for needle syringes, individuals that take insulin and things like that. So you don't end up poking the garbage bin or anybody. But these are like $5. Get one off eBay or Amazon, and again, I just put all my razor blades in there, and you know, it's probably a 1/4 inch full over the year, you know, a year. So it take me years to fill this, and then when you're done, the lid's locked down, and you toss it in your garbage, and everyone's good. So what I'll do here is I'll just lay this out for the 5 1/4-ish inches, and I'll typically trim the one end again, and I just put a dot here. Again, this isn't rocket science on the length, because when I actually mount it on the board, I'll go back and cut it to the right length. So I'll pull this out to, again, put the ribbon on the horizontal line here on my little cutting board, cut mat, and then I'll put my rule on the vertical axis, kind of roughly on where the dot was, and then just lightly go over it for one. This is a new blade, so it may take fewer than, so I took 3 or 4 passes on it. So now I've got basically 5 1/4 chunk of the 28 gauge ribbon cable, and you can notice on here there's a red stripe that they dye on this cable, and that's indicates pin 1. That's kind of the industry standard on all these ribbon cables and different devices. So I don't need the cable. I'm just going to do one here for the sake of argument. So we'll get these little header adapters out. This is the end that retains it, drives it in. So on here, in this end, basically what these are is just a little V, and then the wire, when it comes into that V, pierces through the insulation and makes electrical contact with the conductor inside. Call these IDC connectors, I believe. So they have 2 detents on these. The first one holds it up for you to get the cable in, and then when you actually compress it and push the cable in, there's a second detent where it locks. So I've got one of these little crimper arbor vices that lifts up, and it tries to keep the 2 surfaces. This part pivots so you can keep parallel pressure, so you get even force all the way down. They do make some different guides on here. This one I use for the 40-pin ribbons as well for the ROM boards. And so typically what I do is get a little pan of ice. I've got a couple of these around, different types. Lock that in, so now I've got a pretty good area. These ones are keyed. The board themselves, obviously, where these plug in on the Williams boards, the early boards are not keyed, but most of the, or some of the ribbons on the factory ones were keyed, so I followed, because there is a little arrow indicator for pin 1, and I'm just kind of good like that. So over the years, I know the pin 1 is on the left side when the key's facing towards you. So basically here we'll feed the cable through. You can see you can run the thing through, so you can put these, multiple. You'll see them on some pinball games and things where they'll stage these connectors throughout. So what I used to do is maybe stick out 1/8 of an inch, crimp it, and then I'd take that razor and just trim it so it's perfectly flush. But the way I've cut these now, and I've done a lot of them, I can get them pretty much right to the edge where they need to be, and everything's clean. So there we go, and I'm going to squeeze really good. And you can see it's perfectly flush on this edge, pin 1. Again with that key down here, a little arrow for pin 1. So here's a board that I've done. You can see when that thing lays on there, pin 1 is on this side, and when you flip the board over on the PCB, there's a number 1 printed there and a 20 on this edge down at the bottom. So these go 1, 2, 3, 4, 5, 6, 7, 8, so on sequentially down to 20 over here. So that's a cable. That's how you make them. Now when you put them on later on in the video, I'll show you where you actually crimp it onto the board. I think I had a couple boards that I have torn down already. So this is one that I've removed the capacitor, I've removed the ribbon, I've removed all of the labels. Again, these will be reused, and what I do is I put a little tie wrap. It's kind of bugging me there. I usually cut that end off just because. I put a little tie wrap, and I have a little label printer. So this is 01, and then I'll have a little Ziploc parts bag. So this is labeled 01. So again, this has all the different labels, a serial number label. This one actually had one from somebody that serviced it. It's got a date code on it, 6981, and they wrote the serial number, and probably I'm guessing the guy's initials who did the servicing on every board had that sticker that I had. I got 2 or 3 of that boards with it when I bought them. So again, I strip them down, then I take these and wash them in simple green, spritz them down, scrub them with the soft brush, rinse them, then I rinse them in an RO water, dry them, bake them in the oven for a little bit to get the water off, and then bring them back down, and then we install the new ribbon cable and the cap and all the labels back on, and then it goes into test, and then I start troubleshooting if there's any any issues on the board. But basically that's the starting point before I even power these things up. So ribbon cable done. So what we'll do now is take one of these boards. Again, these 3 I just set here. I've got 4 over here that need torn down, and basically I have one with the CW. This is the manufacturer. These are the same ones I'm buying these blue ones, actually, same company. I'll show you how to remove one of these ribbon cables, and then there's the SAE is the name of this manufacturer for these black ones. Again, when Williams was making these, they were buying them from whichever vendor could supply them. So I'll show you these ones first. So using a small flat blade screwdriver, you come over the edge, and on the side closest to the PIA, there's actually a little overlap. That connector, there's an edge there, right in here. So you just come over, give it a little pop. There you go. Just kind of a little prying. And then I have one of these little chip lifters, WIA tool. It's got kind of a double prong tip on it, and I just put it in this edge that's lifted on the right side here. And I'll just kind of walk it gently using the old ribbon cable as the fulcrum point, so I'm not damaging any of the plastic. And then that's pretty much it. So that's off. And then you can see the little piercing post here coming off the PCB. And again, I just kind of grab this and pull it in the same axis, because you don't want to pull down because you can bend these, so you basically just want to pull away from them off to the right or left or whichever axis. Trying to do it on camera here is a little... Oh, look at that one. Tore split right down. So there's the old ribbon cable off the board. And again, this goes right in the garbage. I've got a little 5-gallon Home Depot bucket. And then what I do is I inspect these things, and I have a pair of these little magnifier doodads here. Magnifier, and then it actually has another lens up in top that you can pop down to get a higher magnification for close-up. So I'm just going to take a quick look at this, these pins here, make sure they're all straight, no corrosion, anything like that. Yeah, see, they look perfect. They look as good as the day it was put in. And then I also look when I did the, that one area back in here in this corner where I did a little prying on, I make sure, sometimes, you'll nick a little bit of the plastic, and I'll just go in with the X-Acto, and that's it. So that's good. So the other thing we'll do now normally after I get the ribbon cable off and that, I'll go through the label removal process. I use some heat and a razor, and I've tried different techniques. I've saturated them with isopropanol, denatured alcohol, some solvent stuff. I've tried just water. To be honest, heat, the adhesive they used is softens right back up. Even if it's all brittle, it'll soften up, and then you can get the razor and it'll lift right off pretty easily. And then I put them back down with a PVA polyvinyl acrylate cement that's water soluble, so it can always undo my work. If somebody else wants to redo it in the future, they won't have any trouble. So let's pull the cap off. Another little pan of ice here. So old electrolytic, bottom's all swelled up. You got your plus and minus here. So I'll put the board in, my little vise. I like to use a little bit of this. People don't like this stuff. This is rosin flux. This is actually RA type, they call it. So they have mildly activated, and this is the pure activated stuff, and it's got the skull and crossbones, deadly. I'm working in a pretty well ventilated area, and I use a very minimal amount, and I transfer this over to one of these little syringe type bottles, and this stuff has a lot of rosin in it, tree rosin, but so I just put basically a drop on each one, and this really transfers the heat well, and it keeps the surfaces clean, and works well. So I'm looking for some solder wick. An open one here somewhere here. Solder wick here. I have some Chemwick rosin. This is size 0.1, and this was a 50-foot spool, and it's almost out. And again, this has flux in it as well. Got a Weller iron over here. I run it pretty hot. I think, especially for desoldering, I've got it about 840 degrees right now. It's pretty much cranked up. So what we'll do is just remove the solder first. And again, when it comes to desoldering, I've got the desoldering pumps, and I've got actually, a rework station that has an automatic pump in it and all that, and I get much better control with the heat and removal with the so there's the old cap. I've got a little bucket under my bench here that I keep all the old parts in. I don't know why, but. And then I'm just going to check to see if there's any more. Yeah, there's a little bit of solder that it went through. These boards with those caps, they wave soldered them. They didn't get a lot of flow up into the top pads, which both the actual connections are on the bottom, but it's just kind of surprising with how the resistors and everything flowed on these boards that. So So what I'm using for alcohol, I used to use, you know, high 98% isopropanol, and Home Depot denatured alcohol. It's pretty much pure alcohol that they add something in so kids won't drink it. But it completely evaporates. It's an incredible solvent. I just have some little t-shirt, old white cotton t-shirt squares I either cut up, or you can buy them. They sell them for gun cleaning supplies. They're just little patches. They take old cotton t-shirts and they cut them in, you know, 2x2-ish squares. So I usually go over with, just kind of soften it with this, and then I use I've got a really good, this is a flux brush. It's not one of those Home Depot that they use for soldering. This actually has I have them with horsehair or hog hair. They're real, pretty stiff. They last a long time. It's a heavy unit. They're $6 a piece, something like that. And I probably have 6 or 7 backups because I like them so much. And the one is kind of flat and flared, a little softer. This one's kind of chisel tipped. Gets down in between the IC pins real well in different areas, cleaning. So you just, if you don't remove most of the flux off by hand, it ends up getting built up and gunked up in these bristles. So I do that. So and again, I am going to wash this board with the Simple Green in the sink, but the Simple Green doesn't really work too well on removing this flux. And I just like to inspect the board, make sure no pads are lifted, make sure the through hole's clear, so I'm not going to have to try to wick the solder out of there. So in terms of other than removing the labels, this board is ready to be washed. So I'm going to pull the labels off, and I'll show you the Simple Green process. See you in a few.